This is section 3.3 part 1, where we are going to graph a system of two inequalities. So remember, whenever you're graphing inequalities, alright, that means shading is involved. Alright, so we want to make sure that we're going to both graph the lines and shade accurately. So we're going to graph these just like if they were in y equals mx plus b form. Alright, only we have an inequality symbol, not an equal sign. So same rules apply though. Alright, you want to plot your b, alright, which is 2. So I'm going to plot my b. From there, I'm going to listen to slope. And my slope here is 1 or 1 over 1. So I'm going to go up 1 over 1, up 1 over 1. The good news is we're not necessarily extremely interested in the intersection point. So if you're slightly off, it's not that big of a deal. Whereas with the equations, we want it to be pretty spot on. So we don't need as many lines. And I actually erased that because I have a less than sign. And that means that it's not solid. This should be a dashed line. Alright, so less than will always be represented by a dotted or a dashed line. If it had a line underneath it equal to, then it would be a solid line. So we've got y is less than x plus 2 over here. Second equation, or inequality, I have a y-intercept of 0. So I'm going to plot a point at 0. And my slope is negative 2. So I'm going to go down 1, 2, right 1. Down 1, 2, right 1. And it's greater than or equal to, so because of that little line underneath it, this will be a solid line. And I've got both lines graphed. Next step is the shading process. So I'm going to do a little check here. We'll do it in red for the shading. You need to check each equation. So I'm going to take the first, or each inequality. I'm going to take the first inequality, y is less than x plus 2. And you want to pick a test point, any test point. The big rule is, though, the test point cannot fall on the line you are testing. So here's my line. I can't pick any point, like 0, 2 wouldn't work, or 1, 3 wouldn't work, because it falls right on that line. I like to pick 0, 0 whenever possible. So for this line right here, it works, because 0, 0 does not fall on that line. So my test point is 0, 0. So essentially what you're going to do is you're just going to plug the values of x and y into your inequality. Y is 0, so I have 0 is less than 0 plus 2. And you just want to evaluate each side of the inequality independently. So 0 is less than 2, because 0 plus 2 is 2. Then you need to analyze this. Is this true? And yes, this is true. If it's true, you're going to shade toward your test point. So for this line, my test point was 0, 0, so I'm going to shade everything in that direction. Now I need to test the shading for the second. The second inequality. This is the first one. Here's the second one. So we have y is greater than or equal to negative 2x. I would love to use 0, 0, but notice 0, 0 falls right on this line. So I can't use it. You can't use any point that falls on that line. So I'm going to default to my next favorite test point, which is 1, 1. I like these points because they're easy to use with math. Zeros and ones, real easy. So I'm going to plug in the value of y, which is 1. It's greater than or equal to negative 2 times 1. Evaluate each side independently, so I'll write it over here. 1 is greater than or equal to negative 2 times 1 is negative 2. So is 1 greater than or equal to negative 2? You need to evaluate that. Think about it. Make sure you're correct, and it is true. So again, I had a test point up here. I want to shade in that direction. Alright, so I'm going to shade up here. And your solution is going to be where the two shading areas intersect. And I can see I have an intersection point here. Alright, so that's my solution. So I go in, make it a little bit darker, and this was my solution. Any point that I pick in here will produce a true value for both inequalities in my system.